Okay, so here are the question. This is the MP question of the strength of material assume. Okay, draw a sharp force and a bending moment diagram for following beam. So here are the some beams, beam A, beam B, and beam C. This question is the most IMP question from 23 and 24 and 25. Okay. Okay, so I usually calculate the first question, then we will calculate the second half together. So first I will explain the terms. So from a one bending moment, sharp force is acting on a mid of the center. It's called B. It's called B, and from A to C, the distance between A to C is a 4 meter, but in the tension between B is 4.k newtons by meter, and A to B is the distance 3 meter, and B to C is distance 1 meter. So first of all, we calculate the reaction at support of A. Step one. It's called step one. Calculate the reaction and support A. Who is A? He is the A. Okay. For a cantilever beam to support A has a vertical reaction. A has a vertical reactions. Okay, A has the vertical reactions. A has the vertical reactions. For cantilever beam supported, A has a vertical reaction. RA of momentum MA, summing vertical forces. So Fy sigma Fy is equals to 0 is equals to RA minus 4.5 k Newton by meter into 3 meter. So where it's come from? This is the bending moment here, and 3 meter is the line. Okay. Summing moment about A. Sigma MA is equals to 0. So minus MA is plus 4.5 kilonewton into 3 meter into 1.5 meter is equals to 0. MA is equals to 25.25 meter. Here is the first step one. We calculating this. Okay. So in the second step, we will sharp force diagram. Sharp force diagram SF at any section X from the free end is given by SFX 4.5 k Newton mx. So here we are usually multiplying the Newton, I mean the bending moment from this to the X. We will find the SF sharp force by the calculating the denoted as a X. So at a C, at C, here are the X is 0. SFC means sharp force. Sharp force is 0. At B, X is equals to 1 meter. We know that X here is a B to C, B from C, X is a 1 meter distance, and SF, the bending, sharp force is 4.k Newton into 1. Usually we are dividing the force into Newton, sorry, force into distance. So what we get 45 k Newton only. Okay. Then at A, X is equals to 3 meter, SF sharp force 4.5 it can it now. Then we will calculate 4.5 Newton into 3 meter is equals to 13.5 Newton. These are the only second step. Then bending moment of diagram BMD. The bending moment of diagram BM at any section X from that a free end C is given by. So here we are BMX bending moment is BM means bending moment. So BM bending moment is equals to 4.5 k Newton into X by 2 is equals to 2.25 X square. At C, X is 0, bending moment is 0. At B, X is equals to 1, bending moment is minus 2.2 by 1 bracket 1 by square is equals to 2.25 k Newton meter m. Then at A, X is equals to 3 meter, BMA is equals to 2.25 meter into 3 meter. 3 meter, then 3 meter, 2.25 3 by cube is equals to minus 20.25 kilonewton m. Here the BMD is a parabolic curve from a OWC to the minus 25 to KNN at A. Then we calculate finding the then write the answers of the all following steps. Answers. Just wait. Okay. Everything is visible. Maybe everything is visible. Okay. Then answer is equals to reaction RA is equals to 13.5 K Newton and MA is equals to 20.25 K Newton. SFD linear increase from 0 at C to 13.5 K Newton. Okay, at from here at A. BMD parabolic curve from 0 at C to minus 20.25 meter at A. Here are the answer for the entire question. Okay. Then we'll enter the second question B. Okay. So गड़बड़ हो गया. In the end of the video, I will provide you all IMP questions of the strength of the material foam. Okay, simply for the next question, here the question of A, C, B for sharp force and bending moment diagram for the following beam. Here the beam is the distance 2 meter and 3 meter and the force is 2 K Newton. Okay, so here I can simply draw a diagram of that question A, and here is what is it? B. Here are the bending 2 K Newton. Two meter, 3 meter. So firstly, B, step 1, simply supported beam with point load. So step 1, calculate reaction at A and B. Assuming moment about A, sigma MA is equals to 0 into 2k Newton into 2 meter minus RB. What is RB? Reaction into B into 3 meter distance is equals to 0. RK Newton meter is equals to 3 meter into RB is equals to RB 1.333 K Newton. So what is summing vertical force? Summing vertical forces are sigma Fy. Here we calculated previously on the step 1 also of the reaction support beam at a tensile beam. Okay, so here are the second beam option. Fy, sigma Fy is equal to 0, react Ra plus Rb minus K Newton is equals to 0. So Ra plus 1.33 K Newton minus 2 K Newton is equals to 0 by 3 is equals to Ra 0.67 K Newton. Hope everything is visible. This is only the first step 1. So can see the step 1 clearly. Then step 2. Step 2. Step 2. Shear force diagram. SFD. SFA is equals to 0.67 K Newton upwards. The shear force will apply on the upwards direction. Okay, between A to A and C, SF shear force is constant at 0.67 K Newton. At C, the 2 K Newton load acts downwards. SFC shear force at C is equals to 0.67 minus 2 is equals to 1.33 K Newton. Between C and B, SF is constant at minus 1.33 K Newton. At B, the reaction RB acts upwards. SFB D is equals to minus 1.33 plus 1.33 is equals to 0. So here are the second step. We can previously also done this, but again for the intentionally we can see that. Step 3 for bending moment. Step 3 for bending movement diagram, BMD. So BMA bending moment at A is equals to 0 and bending moment at B is equals to 0. Simply supported ends. Here are the simply supported ends. BM bending moment at C, BMC is equals to RA into 2 meter is equals to 0.67 K Newton into 2 meter is equals to 1.37 and 34 K Newton meter. I think the meter is not coming. No, K Newton dot meter आएगा. 1.34 K Newton dot meter. Okay. Then we will find the answers. And then we will write the answers of this equation. Reaction RA is equals to 0.67 K Newton dot RB reactions 1.333 K Newton. SFD constant 0.67 K Newton A to C constant minus 1.33 K Newton to C to B. BMD linear from 0 to 134 K Newton point itna point sorry dot M A to C is linear from 1.34 K Newton dot meter to 0 C to B. Here are the second numerical we will calculate it. So also we can find the third beam rate. What is the beam rate? And then we can find it. Third is the cantilever beam. Okay, so after we can see this, they are the one revision of this beam center from B, simply supported beam. Calculate the reaction at A and B scaling moment about A. So sigma MA is equal to 0. So 20 K Newton into 22 meter minus RB into R 3 meter is equal to 0. 4 K Newton dot M is equals to 3 meter into RB is equals to 1.33 K Newton. Summing being vertical forces, sigma Fy is equals to 0 is equals to Ra plus Rb minus 2 K Newton is equals to 0. Ra plus 1.33 K Newton minus 2 K Newton is equals to 0. Ra is equals to 0.67 K Newton. And here, sharp force diagram, SFA, sharp force diagram, SFA 0.67 K Newton upwards in the upward direction between A to C. SF is constant at 0.67 K Newton. SF C sharp force at C is equal to 0.67 minus 2 is equal to 1.33 K Newton. Between C and B, SF sharp force is constant at 1.33 K Newton. At B, the reaction RB acts upwards. SFB sharp force B is equals to minus 1.33 plus 1.33 is equal to 0. Both are cancelled. With bending moment diagram, BMA is equal to 0 and BMB is equal to 0. Simply supported ends, BM at C, BMC at RA plus BMC at BMC is equal to RA into 2 meter is equal to 0.67 kilonewton into 2 meter. So is equal to 1.34 kilonewton meter. The answer reaction RA is equal to 0. RA is equal to 0.67 kilonewton, RB is equal to 1.33 kilonewton, SFD constant is equal to 0.67 kilonewton, A and C constant minus 1.33 kilonewton, C and B. BMD linear force from 0 to 1.34 kilonewton meter, and A to C is linear from the 1.33 kilonewton meter dot C to 0, from 0 to C and B. So here are the all division of the bending of the simply supported beam at point load. Then we are finding the cantilever beam. The third question, cantilever beam. How it is diagram? See the diagram first.